All right, so we are down to our last method.
Hmm?
All right.
Last one.
Now, this method is kind of interesting because up to this point, we have been checking for occlusion. If we get occluded, or if or basically if there's going to be a camera collision of some sort, we move the camera forward. But what happens if, well, let's just kind of draw this out. Let's say we've got a little building here, and our camera is up here looking down, and here's our character. He's just kind of sitting here. Our camera's looking down, like so. And if the character moves inside, of course, we've established that the camera has got to get a lot closer so that it can kind of stuff itself underneath the ceiling, because we don't want the ceiling to be occluding our character. What happens when the character makes it back out here? We don't want the camera to stay at this distance, and we've already seen that because you have to roll the mouse wheel all the way back, and that gets really annoying. We would like the camera to blend right back to where it was. Now to do this, we're going to create a method called what exactly?
I believe it is called reset desired position.
Reset
or distance.
Desired distance, that's right. Desired distance. Now, there are some interesting considerations with this process. We can't just handle it exactly as I have just shown. It's like you have to take in the little things that the player might do in the meantime. Now, what do I mean when I say that? Let's say that we're not just going underneath a little cover here. Let's say our character is going from a great big outdoor world into an indoor building, a dungeon, whatever, that they're going to be in for a long time. And while they're in there, they make their own adjustments to the camera, and they get the camera closer, and they tweak it out to accommodate their indoor setting. Do you automatically want the camera to fly back to some previous position that they might have had like an hour ago? No. You've got to take into account any changes that might have happened since we've occluded. Now, the reason that becomes important is that in our occlusion process, if you recall, we were utilizing distance from the player. We were also utilizing our desired distance. And we were setting these both to be the same value once we occluded.
Right.
The reason we did this is so that once we got underneath an occluded object or around an occluded object, it could be something horizontal as well as vertical. I mean, I'm just giving an example. Once we got around that, we didn't want to start smoothing to a new location. Basically, we've had to correct what the camera was doing. Let's just hold it here until the player says otherwise. And that's a great way to describe it. We've had to automatically adjust the camera, leave it here until somebody says something else. Now, we still need a few things. See, now that we've got this desired distance moved to the new location, we need something that lags behind. We need some way to at least calculate where we were prior to occlusion. If it is something like a really quick bridge that the player just goes under, yeah, we want to snap down low, and then as soon as we get done, we want to move back out to where we were.
Right.
If while the player is underneath that bridge, they zoom the camera in close or make their own tweaks or adjustments to it, then we don't want to jump back.
Right.
Because at that point we'll have said, well, the player knows what they're doing. They've made some sort of change to the camera. Let's not put it all the way back out here. They've changed things. This is where we're going to get a new recorded position, which we're going, or I'm sorry, a new recorded distance to be more accurate.
Right.
And this will be called pre-occluded distance. Now here's the trick about pre-occluded distance. In the best of circumstances, meaning in any situation where you're not occluding under normal circumstances, desired distance and pre-occluded distance are like friends. They'll be hanging out with each other all the time. They'll always incidentally be in the same location. However, as soon as we get into a situation where we have to occlude, well, desired distance is going to have to look over at pre-occluded distance and say, hey man, I got some work to do. You just hang here for a while, I'll talk to you later. And then they're going to split off like what you see here. Now I'm going to redraw some of this to be just a little bit bigger, not because I think it's a bad drawing, but I think, you know, we could make it just a little bit clearer if we brought it sort of front and center. So we've got our character in a covered state when they're underneath something. We've got it when they're kind of standing outside just before they enter, and then I'll put them way out here in an exited state, which, normally we might want a little more room to do that, but you get the idea. So we start off with the camera out here. I'll do a really simple camera. And we have our distance. Then we have inside, where we have a much shorter distance because we've adjusted because of occlusion, and then we get back outside, and we don't really know what's going to happen out here yet, so I'm actually going to leave this blank. So when we get started at this point, we have 2 points. Now these are both in the same location. I'm just drawing them separately so you can see there are 2 points. At this stage of the game, we would have desired position, provided we're not I'm sorry, thank you. I'll keep messing that up, and Lee will keep smacking me. We'll have desired distance just sitting here. That is, of course, provided that we're not rolling the mouse wheel and trying to move things. This is kind of a calculation, all things being equal, right? And then we'll also have our pre-occluded distance. They will both be sitting right on the camera. Desired distance updates under 2 separate factors. Desired distance will update if we roll the mouse wheel. It will also update if we're occluding. Yes?
Yes.
Okay. So if we roll the mouse wheel, and let me just draw, there's a mouse wheel up here. So here's our mouse, and there's our mouse wheel. If we roll this guy forward or backward, that will update our desired distance, and that's how we get our smoothing in a non-occluding world.
Right. Because we have our distance, which is our actual distance that our camera is at. Our desired distance, if the camera is not smoothing between 2 points, distance and desired distance are equal. The moment they change, desired distance is going to sit there as a goal for distance to seek. That smooths us out. Right,
exactly. So desired distance will change with the mouse wheel, but desired distance has another role as well, meaning if we have to occlude, or if we have to make an adjustment because of occlusion, then desired distance has to update without the mouse wheel. It's got its own update system that will take over. Pre-occluded distance only updates because of the mouse wheel and for no other reason. So pre-occluded distance would just hang out here. If you didn't touch the mouse wheel, pre-occluded distance would just continue sitting right out here outside of our roof. The problem, and it's not the problem, it's just the consideration we have to keep in mind. What happens if the player's going to spend a lot of time under here and they want to adjust the camera for their indoor location? The first thing they're going to do is roll their mouse wheel, and as soon as they touch their mouse wheel, pre-occluded distance is going to say, oh, the player's making an adjustment to the camera. I'm going to immediately hook back up with my good friend, Mr. Desired Distance, and jump right back to here. Basically, what that means is if we have made some sort of occlusion adjustment and you touch the mouse wheel, we don't worry about pre-occluded distance anymore. We're not even worried about occlusion anymore because now the camera's just closer.
And the only way we would worry about it again is if inside of that room there was something else that occluded the camera and forced it to move.
Exactly. And that just takes the problem and minuscules it down. We get another version of it. But again, we're explaining this in kind of an all things being equal circumstance, where if you are occluded by some object, in this case we've got like an overhead, and you don't touch the mouse wheel, then pre-occluded distance will just continue to hang out here until you're no longer occluded. He just becomes a goal. We'll constantly be checking this goal. As a matter of fact, pre-occluded distance is going to get his very own little pyramid. We'll constantly be saying, hey, is pre-occluded distance still occluded? And I'll just write that down.
Pretty much any time desired distance is less than, well, not pretty much, every time pre-occluded distance is greater than desired distance, we're going to continuously do checks with another pyramid to see if the clip plane, if the camera was at the pre-occluded distance, would be occluded or not.
Right. And this is we're actually going to have 2 pyramids to make this happen. We've got the one where the camera sits that we've already seen. We're going to have a second one that we're going to calculate just to make sure that the pre-occluded distance isn't occluded. The moment that becomes true, or the moment that it becomes no longer occluded, if pre-occluded distance is still sitting out here at this point, then what we're going to do is blend the camera back out to here where it was prior to occlusion. The only thing to keep in mind, as I mentioned a second ago, is that pre-occluded distance will jump to the location of desired distance if there's a mouse wheel input. Because the system is basically saying, oh, well, they're occluded, they're indoors or they're underneath something, but if they're moving the mouse wheel, that must mean they want to customize the camera from this point. Occlusion is no longer a factor. You just have a new location entirely, so we can stop making these checks, and pre-occluded distance just gets set to wherever the camera happens to be at the time.
Right.
That's everything. I mean, that is how this works. It's a reset value that is available to you until you adjust the camera, at which point you don't need to reset anymore.
Right.
That's the easiest way to say it. Now, what do we need in order to make this happen?
Quite a bit, actually.
Yeah, okay. Well, let's just kind of talk about it. Can you bring me the keyboard? The keyboard's like a mile away from me right now.
Yeah. I keep hiding it every time I
know.
do.
Seriously, it's like it's halfway across the room now. So, what do we need? First off, we're going to need a pre-occluded distance. I'm just going to, because we've already mentioned it, I'm going to write it down now.
Yep. This will be a private field that we store.
This will be a private float, yeah?
Yes.
Or just a var?
Yep. Well, it'll be a private float.
Okay.
Because we don't want this to be set by the user.
Okay. Now, what else do we need in order to make this happen?
Well, we're going to need to have a separate distance smooth just to handle when we're resuming back out. Because when we have a normal mouse wheel, we'll have one speed. But if the camera is automatically panning back out, we want to be able to control that separately.
Okay.
So we'll have a...
So if you wanted the overall feel to be like the resuming or the going back to where you were, the returning to your pre-occluded distance, if you wanted that to feel like a quick jump, then you could set that separately. That's what you're getting at? Okay.
Right. Or if you wanted it to be a smoother transition, you could slow it out as well.
Makes sense. So this will be called what?
This is a public float that's called Distance Resume Smooth. Now, because we have a distance smooth and a distance resume smooth, we're going to have another private float that we're going to call distance smooth, and we're going to name that with a lowercase d. Now, what that does is at different points in the operation of our TP camera, we're going to assign distance smooth to be either the value that's held in distance resume smooth or distance smooth. That's going to control when we're using one smooth or the other in our smoothing method when we're calculating desired position.
So you mean like whether we're using the good old-fashioned camera smooth that we've been using up to this point without worrying about occlusion,
right? Or
the special smoothing that we have applied when we're going back to our pre-occluded distance.
Right.
Okay.
And to achieve that, we basically have to have its own little field to keep track of.
Right, and we'll just kind of swap out between the two as we need them.
Yep.
All right, anything else?
Well, there's some considerations that we're going to have to do. There's some methods we got to add functionality to.
All right.
Particularly the handle player input, because now when we move the mouse wheel, we have to make sure that the pre-occlusion distance is assigned to equal desired distance. Because if you remember way back when we created the handle player input, we're calculating the desired distance based on how much the mouse wheel has moved, subtracted from our distance. So we calculate a new desired distance, we set pre-occlusion distance at the same time. That's how we pull off that bringing those two back together.
Right.
We also set our distance smooth to equal our main distance smooth or our normal distance smooth. We're saying at this point we're in normal mode, we're going to use the distance smooth that we expect.
You mean our large case, uppercase distance smooth?
Yes, our uppercase distance smooth.
Okay. Now, is that handled in handle player input?
Yes.
Okay, that's what I thought.
Yep.
Try to remember where everything is.
Yep. All that is handled inside of player input.
Okay. And really, the idea here would just be determining whether we would be using the distance resume smooth or the
distance smooth.
Okay,
right.
Every time, sure I understand.
Yep. Every time we move the mouse wheel, we're going to switch back to the distance smooth, which is the uppercase distance smooth.
Yeah. So you get kind of the same behavior that I was describing with our pre-occluded distance. As soon as snood, that's awesome. As soon as you move the mouse wheel, then you've kind of reset everything.
Yep, we're back in normal mode.
Yeah, it's like you occlude, and it's almost like I'm stretching here. So all of you programmers, remember, I'm just kind of theorizing. It's almost like you enter an occluded state, and as soon as you touch the mouse wheel, you break out of that. And I say almost because we're not dealing with states. I'm just trying to find a common ground to describe it. Or you say a mode. It's like we are now in our occluded mode. We're behaving as if we have occluded. We know that at some point we're going to return back to where we were when we're done being occluded. Until you touch that mouse wheel. Then everything's like, oh, okay, well, we're not even going to be occluded. Yeah, you want to be here. So now we reset everything. All right, so, and the other one will be just distance smooth.
Right. Well,
which I've got to break over a couple things.
Yep. Well, you've got the casing wrong. Distance smooth is going to be capital D on the bottom and lowercase up there. Yep.
Woohoo. I knew that. All right.
So we'll switch between those two types of smooth. We'll use the distance smooth capital D if we've moved the mouse wheel. The moment we become occluded, we're going to set distance smooth, the lowercase d version, to equal distance resume smooth.
Yep. If we're just occluded, we're going to switch over to this guy. As soon as we touch the mouse wheel, we're no longer really considered occluded anymore, and so we're going to go back to our original.
Right.
What else?
The other thing is when we first reset the game or first start, we're going to set pre-occlusion distance to equal our current distance. This is just to get everything in an initial state.
So pre-occlusion distance. I'm going to abbreviate that. We're going to set this equal to our current distance. Is that what you said?
Yes.
All right.
Now, this is just kind of the stuff that we have to thread back through the rest of the program to make this work.
Sure.
We still have to do the method that is going to reset our desired distance.
Right, which is kind of where the whole thing started.
Right. Now, this method is going to check to figure out whether or not our desired distance is less than our pre-occlusion distance.
So, yeah, I'm going to make sure that I've got that. If we draw that out, because you're going to write it out in code.
Yep.
If I write it out in words, I'm doing the same thing you're doing.
Right.
So what we're going to do instead is I'm going to draw a picture, because I like pictures better anyway. Here's our character, and I'm not even going to worry about the camera. I'm just going to worry about this in the sense of two different distances from the player. Now, say what you said again, that first check.
If desired distance is less than pre-occluded distance.
So that would mean that desired distance would be somewhere like here, while pre-occluded was still lagging behind.
Right. If this is the case, we know we're in a occluded state, and we need to start checking.
We got to be careful about using occluded state.
This is true. Our camera.
We know that we're occluding.
Right. Our camera was occluded, and we haven't reassigned the distance that we really wanted our camera to be at.
Right.
So we're going to look to see when that distance that we had wanted to be is no longer occluded.
This is because we're going to be doing some checks. Of course, we've got constant checks coming here, but the whole time we're still considering ourselves to be occluded. We've got to run checks all the way back to our pre-occluded distance as well.
Right. And we have done all the coding ahead of time to handle that. Way back when we were talking about breaking out the calculate position from the calculate desired position, why would we ever want to do this? This is why.
Yeah.
Because we can now pass in our current mouse X and mouse Y with our pre-occluded distance and calculate where that camera could possibly be, do all of our checks against that position, and determine whether or not that position is free. If that position is free, it's time to move our camera back out.
Right.
And that's what this method does for us.
Right. Its job is going to be rendered completely moot if we update the mouse wheel, because at that point we're no longer considered to be occluded.
It's a fairly simple idea, but extremely difficult to convey sometimes.
Yeah, it can be tricky to understand because we have this separation of our pre-occluded distance and our original desired distance. Because at the outset, it's almost like you'd want to ask, why don't we just use desired distance? Why do we have to have this separate one? And that's because we needed our desired distance to help us deal with our occlusion motion. As we repair any occlusion problems and slide the camera forward, we've already utilized desired distance as much as we can. And so now we need something else to lag behind to record that original location so that we could blend back to it. At the same time, we've got to keep in mind that the player's not always going to want to go back to that. And so we've got to give them the choice. We've got to give them the opportunity to say, no, I want to bring the camera even closer so that when they get back outside, the camera doesn't just magically fly away for no reason whatsoever.
Right.
That's it. So that is going to wrap up the theory of this video. I hope I hope it didn't make it too over-the-top complicated, but I mean, it can be. And I've tried to explain this to people myself, even having it explained to me. I had to go over it a couple of times to make sure I understood exactly why we were doing everything we were doing. So if I ended up beating a dead horse, I'm sorry. I just want to make sure there's no confusion.
Well, it was fun. It's like when Zach kept bringing up, well, why don't you do this? I tried that. It didn't work. It's like, well, what about that? Yeah, I tried that one too. That didn't work.
Right. And so it just boils down to this does work, and it does allow for some flexibility for the player to determine at what point we want to consider ourselves no longer occluded. Are we just moving the camera close and now we're just going to play as if we're indoors for a while?
Right. And the big trick to know is this camera system's predictive, and that's why we have to do it a little bit different. Right. Our desired position, our desired distance is where we would like our camera to be. It's not where it actually is at any point in time. And all of these iterations that we've been doing and these checks are happening between frame draws.
That's right.
So
with that, I think we're ready to jump in and start coding up this final method and I guess make the final attachments to get our system hooked up. So that will wrap things up for this video. I guess will be our last theory video in this series.
Yep.
Thanks a lot.